Hello.
All right, we're going to get started. Just a reminder to everybody to put your cell phones on vibrate and make your deck phones as quiet as possible. Our next speaker is Roger Dingledine. Roger Dingledine, the creator of Tor, also known as the Onion Router. He's going to give a presentation on the recent developments of Tor. On a related note, at 7:30 in this room, there is going to be a talk on a meeting on Tor development during the 1 hour break at 7:30. So here is Roger.
Okay. Can you all hear me well enough? I hear an echo, so it sounds good. Okay, I'm Roger. I'm going to be telling you a little bit about what's going on with Tor these days. There are a lot of different things that we could talk about, so I'm basically going to try to preempt the first 40 questions that you might ask and present answers to those, and then maybe there will be time for a few questions after that. So there are a lot of things we could talk about. I'm going to give you a very brief crash course on Tor. How many people here think they know how Tor works? Excellent. Okay. So it'll be very brief indeed. And then I'll give you a little summary of what's been going on recently in terms of things we've developed. And then maybe the juiciest part, policy discussions, law discussions, censorship, how Tor interacts with the rest of the world. And then some of the technical things that we'd like to do down the road in the future, stuff we're hoping to get to in 2008, 2009. And then there are all sorts of things on the website that we need some help with, and I'll list a few of them. Okay, so big picture, Tor is a free software system, open source. It's an anonymity system. The idea is that you can browse the web or instant message without people being able to figure out if they're looking at you where they're going to, and if they're looking at the website or service where you're coming from. It comes with a full specification, documentation. Several German groups have built their own compatible Tor clients. Ask me later on for stories about why it's useful to have more than one implementation, if the phrase 16-bit AES means anything to you. And they're also useful to have a lot of different papers out there for people researching Tor, figuring out how to make it better, how to attack it. We're pretty much the standard for what you write your research paper about these days because we have that specification. There are about 2,000 active servers, relays out there, and a whole bunch of users. It's an anonymity system, so it's a bit hard to tell how many people we have really, but I'm guessing maybe 200,000, a quarter million Tor clients are running right now, and they're pushing over a gigabit per second. I haven't counted lately, so maybe it's up to 2 gigabits per second. So we're rivaling like Hotmail and Wikipedia and stuff in terms of the amount of traffic that we're pushing. As of the end of last year, we're an official 501c3 nonprofit in the US, which means that if you're in the US, then you can donate money tax deductibly to us. I just chatted with Andreas from the CCC last night, and they have set up a bank account for the CCC accepting donations for Tor. So now we will be tax deductible in Europe also. Hopefully info on that will be up on the website soon. We've got 3 full-time developers, a whole bunch more dedicated volunteers. Some of them are anonymous to us. They use Tor when they're submitting their patches and talking on IRC and stuff, so that's kind of an exciting community. So another interesting point from us, we were originally funded by the US government, the US Navy, to build security systems so that they can protect themselves. From there, we were funded by the Electronic Frontier Foundation. Most recently, we're funded by a group called the International Broadcasting Bureau. They're the folks who fund Voice of America and Radio Free Europe and Radio Free Cuba. They've got some websites in the world that some folks can't reach, and they'd like to fix that, and we sure wouldn't mind fixing that. So we've got a variety of different organizations that care about having Tor exists, which makes it more exciting. Okay, so speaking of a variety, there are a lot of different types of users out there. When I'm talking to my parents and my grandparents, I say that I'm working on privacy systems. When I'm talking to Google and Walmart and so on, I say that I'm working on communication security or network security. And when I'm talking to the US government and other governments, I'm working on traffic analysis resistant communication networks. And And the exciting part is that if you go up to Walmart and you say, you need privacy, they say, no, privacy's stupid, we don't need privacy. And if you go up to the government and you say, you need anonymity, they say, oh, anonymity's scary, I don't need that stuff. But if you explain that they need traffic analysis resistance, then they're like, oh yeah, of course, we've got all these things we need to do, I don't want somebody looking at what web pages I'm looking at. But that's a separate talk. That just gives you some variety of, some sense of the variety of organizations that are using it. We've got individuals, human rights, civil rights, corporations, law enforcement, government, and the reason why Tor is so secure, so anonymous, so private, so traffic analysis resistant, is because it has all of these different groups joined into the same anonymity set. Okay, so how do you build one of these things? How do you build an anonymity system? The easiest way is you put a big computer somewhere and you proxy everything through it. Maybe you run some huge computer in San Diego and all of your users show up there, and the websites don't know where Alice is coming from. That's great, but what about a big central point of failure? What happens if you bribe the janitor at their colo or any other list of ways that it could fail? So the goal for Tor is we want to distribute the trust so that you go through several different hops. And the idea is if somebody's watching the first hop, they know Alice is using Tor, but they don't know what she's doing. And if somebody's watching the last hop, they know somebody is talking to Bob, but they don't know who is talking to Bob. And if they're watching both hops, then we're screwed because traffic analysis works pretty well. Statistics, if you can see the traffic on this end and that end. So that's the brief overview of Tor. Hopefully it's not too surprising. There's also crypto involved. I imagine many of you know this because you all raised your hand. But I guess the key point to notice is it's encrypted on most of these links, but once it leaves R3, once it leaves the Tor network, it is whatever you sent. If you're using SSL, then you've got end-to-end encryption. If you're not using SSL, then you don't have end-to-end encryption. You get the same security properties as you would if you're hanging out in Starbucks or something like that. Okay, so that was a very brief crash course in Tor. Feel free to interrupt me if I say something that makes no sense. Otherwise, I'll hope to have some time later on for some questions. Okay, so what have we been up to? There are a bunch of different interesting things that we've done over the past year. One of them is a new version 3 directory protocol. So right now there are sort of two phases for how Tor clients learn about what the servers are. The first phase is that they need to get a big list of all the servers that they could use. And we want to make that list as tight as possible. So it's basically a little summary with a few lines for each server. And each line says, this is the key fingerprint for the server. This is his current IP address and port. This is the hash of the descriptor that you should get from him and the timestamp for when that descriptor came out. And a few flags about whether we think he's fast or stable or running or not worth using, stuff like that. So there are two phases. The first phase is you get that list, the little summary of them. And then the second phase is for all the servers that you want to use, you go out and you fetch the server descriptor for them, which is a signed blob that says these are my keys and exit policies and stuff like that. So we've been focusing lately on making that first phase a lot faster. Originally it was you go to every single directory authority, there were like 5 of them, and you fetch a status summary from every one of them, so you've got 5, and then you look at them locally and say, well, 4 of the 5 believe in this, so I'm going to believe it. But only 1 of the 5 claims this, so I'm not going to believe it. But the fix we did was we made all 5 of those directory authorities talk amongst each other first and build one consensus directory, and then they all sign it. So that means that the poor guy in Iran on a modem doesn't have to download a megabyte of stuff, and he only has to instead download 200K of stuff. So that's an improvement. There are a bunch more improvements that we could add. We'll get to that later on. Another thing we've been up to, it turns out that if you are a big firewall, corporation, government, something like that, you can block connections to the Tor network. There were a bunch of different ways to do that. This was the talk that I gave last year in SAL 1. So the idea is there are 2,000 servers, sure, but those could be blocked. They're in a public list, there's a directory, you go grab the consensus and you filter all 2,000 IP addresses at your government firewall. So the idea is we've got a few 100,000 users. What happens if we give them a little button in Vidalia that says, help censored users reach the Tor network? And if you sign up for that, then you become what's called a bridge. So you've got the blocked user, goes through the Tor user to the rest of the Tor network. And that means that the user doesn't have to exit anywhere, he's just relaying, and he doesn't have to pass very many bytes, maybe 10 kilobytes a second, 20 kilobytes a second, and he's not on any list that will get people angry at him. So these bridge relays are a new feature that we've added over the past couple of months. And there are a bunch of other pieces to making it hard for people to block connections to the Tor network. One of them is that our directory requests are now encrypted. It used to be that Tor spoke two protocols on the wire. One of them was HTTP when it's doing directory fetches, and the other one looked like TLS, SSL, when it's actually talking to other Tor servers. Now we move all the directory stuff onto that encrypted connection, so now you just look like you're talking SSL. And we're working also on making the TLS handshake look more like a Firefox talking to an Apache. When we first started out, we tried to follow the specifications, and the spec said, when you're writing your SSL certificate, put your common name here. So we wrote, Tor in the SSL certificate, because that seemed like a good idea at the time. Turns out if people are looking for strings to filter on, that's probably not the one you want to write on the wire. Okay, so we've also got integration into Vidalia, and there's also a URL you can go to get a few example bridges. So I'll very briefly show you that Vidalia exists. So here's the interface for Vidalia. Unfortunately, it's in 600 by 400, so it's really big compared to how it would be. But there are a couple of new features that we've added. One of them is My ISP blocks connections to the Tor network. As soon as you click this, then it switches over to using encrypted directory requests. And then you can also add some bridge addresses if somebody happens to tell you some of those. And then another option over here in the relay, normally you run Tor as a client only, but now I want to help censored users reach the Tor network. So that's, now I've signed myself up as a bridge. So it's pretty easy to do from that perspective. Unfortunately, there are still some other tricky things that I'll talk about later on, like how do I make sure that my Linksys firewall is actually port forwarding correctly and all that crap. Okay. And then if you also want to learn some public bridges, if you go to bridges.torproject.org, we'll give you a few, and the answers that you get depend on what time it is and what IP address you're coming from. So if you want to get a few bridges, you'll always get some, but if you want to learn all of them, then you need to come from a lot of different places around the internet. If you want to learn more about this whole blocking resistance thing, look online for last year's talk. Okay, so we've also got an improved Tor button. Probably most of you know Tor button as that little thing in the bottom of your Firefox that says Tor enabled, Tor disabled. The development version has a whole lot more features. It's got, I want to turn off my cache, my cookies, I don't want to leak my time zone when somebody sends me JavaScript that tries to learn that. There are like 30 different attacks. Another example is if you go to a website that hands you a CSS or JavaScript thing that refreshes the site every 60 seconds, so you just leave that running in the background, every 60 seconds it reloads, and then you click Tor disabled, so you turn off Tor. 60 seconds later, it reloads again, except now you're not using Tor, and now they win. So there are all sorts of attacks like this that are application-level attacks. Tor was originally designed to hide your IP address, but what you say over it, what you do, hey, that's not our problem. Unfortunately, users care about that second part too. So we've been working on handling the data application anonymity layer also. Okay, other stuff we've been working on. It's a lot easier to be a relay and a client at the same time compared to last year. We rate limit relayed traffic separately from your own traffic. It used to be that if you said, I want to rate limit to 20 kilobytes per second, then you would not only limit other people's traffic going through you, but you would also limit your own traffic coming in to 20 kilobytes a second. And that made everybody angry, so they turned it off. So that's one example. We also detect our IP address a lot more easily. Every time you go do a directory request, the directory server says, and here's the IP address I think you are. So that means that you can notice pretty quickly if you're on a dynamic IP and you've changed. We also do bandwidth estimates. As soon as you start off your Tor client, your Tor relay, it will build a bunch of circuits back to itself and send cells down them so it can figure out how quick you are. So that bootstraps you into the network faster. We also added write limiting as well as read limiting. We used to just rate limit the bytes coming in. Now we rate limit both. And we also have traffic priorities, so you can specify certain connections should go out first, and the rest of them can fill in whatever's left. There are also a whole bunch of good research papers in 2007. Here are just a few examples. At ACM CCS in Washington, D.C. a couple of months ago, Nick Hopper from Minnesota had a great paper on client latency attacks. He basically mapped the entire internet in terms of how many milliseconds on average it takes to get from any point to any other point. And then he ran a couple of Tor servers and watched the latency between when stuff was going back to Alice and when he was receiving connections again. So even though he wasn't able to watch the first node in Alice's path, he was still able to say, hey, it takes about 70 milliseconds, and here are the sets of places in the world that are 70 milliseconds for me. So I can now narrow it down to, I bet the client's in Virginia or something like that. So that's still an ongoing work to figure out exactly how effective these attacks could be, but potentially very effective. So the next step would be to figure out how to defend against this sort of thing. Another good paper, Stephen Murdoch, who's I think in the audience over there and presenting next, had a paper at PET on sampled traffic analysis resistance. So he looked at internet exchanges. There's a really big one in Amsterdam where they push through gigabits per second, so they can't record everything. So they just sample it. They take one packet out of every 2,000 packets. So then he looked at logs like that, saying, okay, what happens if you just sample, and figured out good traffic analysis attacks where you just get a smidgen of information on this side and a smidgen on this side, and you can still figure out, yeah, this person was talking to this person. So that's kind of scary too. Another interesting paper at WPES a few months ago, there was this fellow who figured out that since Tor clients believe the bandwidth and uptime claims of Tor relays, then you can lie. You can say, oh yeah, I can handle a gigabyte per second and I've been up for 17 years. And all the Tor clients will say, oh, that's great, he's so fast and he's so stable, I'd love to use that one. It turns out that you can run a small number of servers without many resources and attract a whole lot of users that way. So we've been moving towards having the directory authorities or other Tor servers actually measure these things, and we take the majority or something like that. So you don't just believe whatever some server shows up with. Tor's guard nodes are looking increasingly good. So the guard node idea is when Alice is connecting to the Tor network, she picks a small set of servers, maybe 3 or 4 of them, and she always uses those as her first hop. And that means that if you don't pick the bad guy as one of those 3 or 4, then you're in much better shape anonymity-wise, because they're very unlikely to be able to see the beginning of your circuit and the end of your circuit. Whereas before we used guard nodes, you just keep picking a random first hop over and over. And eventually you're going to pick a bad guy first and last, and then you lose. So all of these various research papers that are coming out, every time I read one, I say, oh, I'm really glad we implemented guard nodes because that helps that attack a lot. And there's a bibliography down there, freehaven.net/anonbib, if you want to read all the other research papers that are coming out. Okay, so that's a little bit of what we've been up to. And then some more discussion. Data retention. Hopefully this is a topic that's on everybody's minds at this point. I've been getting a lot of mail over the past couple of weeks saying, I don't know if you're aware, but soon all the Germans are going to log everything, and should we stop working on Tor, or what should we do? So there's a lot of discussion here, and you should keep going to the other talks on it, but I'll give you a couple of ideas. The most common things that I answer when people are talking to me about data retention. One of the big ones is, remember Tor's threat model. If there's an attacker at the beginning of the circuit and at the end of the circuit, then, assuming they know some statistics, they're in really good shape. So it's not a matter of having at least one node in the circuit be honest. We need to have the beginning and the end not both bad. So if you have one node in Germany that's logging everything, and it's at the first hop, it's your guard node, and then you've got some website, say, in Germany, that's good enough to break Tor. So we can't just say, limit at most one node in Germany. We have to be a little bit smarter than that. Maybe we have to say, logging nodes in the first hop. And then another question, what do we mean by logging? How many layers of logging are there? Everybody thinks about this in terms of, if I log at my computer, then we'll have logs, and if I don't log at my computer, then nobody will know any of the packets that went back and forth. What happens if your ISP writes everything down? What happens if your ISP's ISP writes everything down? How many layers of logging are we talking about? Are there going to be 5 different copies of all these databases? And if you can break into any of these 5, then you win and you learn everything that's been going on at that ISP? Hopefully we'll find out over the next year. And then how safe are these logs? Who gets to access them? I've heard the phrase real-time access. I guess that means we distribute public keys to every policeman and we hope that they never lose them, and oh my God, that's never going to work. We'll find out what that turns out to mean as people start to clarify these. But I guess the key point is none of this is going to be enforced until 2009. So 2008 is when we figure out what they really mean. So from the Tor development perspective, we don't have to rush to implement something next month because we don't know what the heck data retention is going to end up meaning. From your perspective, that means you've got a whole year to fix your crummy laws. So get out there and advocate and teach people and figure out how to make this law go away. As an example, like 6 or 7 years ago when I was first getting into this privacy advocacy stuff, I was talking to the chief technology officer of Bermuda, and I was there with a couple of other cypherpunks. And Adam Shostak went up to him and said, there's this crazy new law that the Americans are trying to push through, and let me tell you about it. I don't remember which super DMCA or whatever one it was. And I said, but that law is crazy. It's never gonna happen. They'll never pass a law that's that crazy. And he pulled me aside afterwards and said, the reason why they don't pass these crazy laws is because people like us tell them about the crazy laws and explain why they are crazy. So that's the story to remember there. Law enforcement. There have been several Tor-induced raids in Germany over the past years. There was a big one in September 2006, and periodically I hear from other people who say, yeah, they busted down my door and 6:30 on a Sunday and dragged away all my stuff and scared my wife, and yeah. So I guess there are a couple of interesting perspectives. I only hear these stories from people in Germany. I don't know what's going on with German law enforcement, but they're really harassing people in Germany in a way that other countries aren't experiencing. So it might be really useful to teach a lot of law enforcement people here how the internet works. There are these things called bot networks, and there are bad people on the internet, and sometimes they do bad things. And often when a computer does something bad, that doesn't mean that the guy sitting at the computer is the criminal. There might be some guy in Russia or Africa or who knows where they are. So one of my hobbies has been to teach FBI officers in the US about internet security and tell them this is how Tor works, and these are all the good users and uses of Tor, so that if they ever encounter an issue with Tor, then they'll know what it is. They won't have to learn all about it in 1 hour and then go arrest the guy in the next hour. So a corollary to that, if you know any German law enforcement who speak English and are open to learning about this stuff, please introduce me to them, and eventually I'll end up in their city and I can give them an overview of Tor and answer all the questions they've got. I'm going down to Stuttgart next week to talk to a bunch of law enforcement there to try to teach them about Tor. The other half of that, lawyers. In the US, I have lawyers following me around saying, I look forward to the Tor case. In Germany, there aren't really that many lawyers who know about Tor and care about defending people. And part of that is because of the US's notion of legal precedent. It's really valuable to get really good lawyers to take on the first case in the US, because if you can make sure to establish a precedent, then you actually change what the law means, in a sense. In Germany, it feels like every case is on its own, and sure, I could defend this person, but there's just going to be 12 more after them, and why bother? So we really need to get more European lawyers to care about this stuff and to understand Tor and to be willing to say, I need to help defend my society, I need to help make sure that these crazy laws don't actually end up causing people to get arrested and causing problems. Go out there and meet some lawyers, civil liberties, human rights, whichever sorts, and teach them about Tor, introduce them to each other. That's one of the big things that we're missing in Germany right now. We need a huge pile of lawyers following us around saying, I look forward to the next Tor case. And then another piece of that, we have a US legal fact written by EFF with 12 questions. What happens if this? What do I do if this? And there's a phone number from a nice EFF fellow who answers. You call him up and you say, I just got this piece of paper from the police and I don't know what it means. Can you help me understand what my rights are and what I need to do? We've got a few people at CCC who can help with that, but we really need more people in general to help actually document these things and teach the operators about what the laws mean in Germany. Okay, other fun stuff. Snooping on exit relays. I have a lot of people come up to me saying, did you hear about the embassy password thing? Yeah, there's been lots of press. I guess the first point is if you plan to wiretap, most countries have laws against it, so check with your lawyer before you want to become a criminal. I guess that's the first step. Another point to reinforce is Tor hides your location. It doesn't magically encrypt all the traffic on the internet. So the traffic that goes through the Tor network, while it's going through Tor, it's encrypted. But once it comes out, again, it's whatever you sent. If you're using SSL, great. If you're just browsing normally, make sure you don't send sensitive traffic. It's the same as if you're using the normal internet. My connection at home in Cambridge, I use an open wireless to connect to my shared community Comcast cable modem connection. Anybody who wants to, within like a mile of me, can watch all of my traffic when I'm not using Tor. So, Tor doesn't magically introduce a new problem, it just shifts the problem. We encrypt your local traffic, but again, there's an issue at the exit node. And I was reading an article that Wired wrote a little while ago, and they were saying those Tor users are so dumb, they don't even use SSL. So I went to Wired's webpage, and they've got a little login link at the top. It doesn't use SSL. They don't even support SSL. So there's a deeper problem here than just we need to educate all the users to click the encrypted link. We need to get all the servers noticing that encryption on the internet might be useful. This has been an ongoing problem for decades now, but I'm not sure how to solve it best other than making more and more people aware of the issues. And there are a few things we might do. Mike Perry, one of the Tor developers, is working on a library called TorFlow that lets you actually test. You build a circuit, you go to some website. If it gives you a bad SSL certificate, then you mark that exit node as kind of sketchy, and if you keep seeing bad ones. So that might be one way to notice. But if people are simply observing traffic, it's pretty hard to notice that they're doing that. Maybe we should do some plain text POP or IMAP logins for dummy accounts and then go see if anybody logs into them. But that's not really an arms race that's easy to win. Okay, other exciting stuff. Theory. Hard to tell. I don't know what people use Tor for. Tor is slow because a handful of people are running file sharing applications on it. Seems reasonable. I talk to people every so often. The Azurius BitTorrent client has a little button that says, put all my stuff through Tor. So I imagine some people are clicking that. How do we make the jerks who are overloading Tor overload it less? There are a few options, but none of them are very good. One of them is we could traffic shape the high volume flows. We could say, well, you've been pushing lots of bytes around, so I'm going to give you lower priority. The problem with that is that BitTorrent considers this an attack and defends itself pretty well. It's constantly making new connections. So we can't really squeeze BitTorrent down that way. Another approach, people periodically say, but Roger, I can run this snazzy new protocol analyzer on my exit node, and if I ever detect file sharing or other bad stuff, then I'll just kill the connection right there. That might work for a little while, but there are a couple of problems. Probably the biggest problem is the liability question. Right now, if you're just a relay, if you just move the bytes back and forth and you don't care what you're sending, then you're just a relay. You're just like a telephone company or an ISP. But if you start taking responsibility for killing certain connections and letting other connections through, then suddenly you might be liable for messing up. If you ever skip a connection that you should have killed, it's your fault that you skipped it. So that's not really a slope that I want to fall down. And then there's the question of neutrality. We're supposed to be a TCP proxy, so shouldn't we proxy all TCP, not just some TCP? And then another fun question, who runs the relays? Once upon a time, at the very beginning of this, you had to send me mail saying, hey, Roger, I'm that guy you met at the conference. You convinced me. I'm running a Tor server. Here's my email address, my PGP key, my fingerprint for the Tor server. That scaled even less well than I thought it would. So that worked up until maybe 15 or 20 servers, and then people started sending me mail from other countries. And do I turn them away and we end up with a Tor network with 30 nodes forever? Or do I say, oh great, another volunteer, you're even from Russia, great, diversity. So there's still a tension here between, do we grow a Tor network that's large enough to handle 250,000 users, or do we make sure that we know every single operator? And I don't know the right answer for that. People periodically come up to me and say, do you think that all the servers out there are just running it to catch whoever's using it? I don't think so. I mean, we've got 2,000 servers, and probably nearly all of them are nice people who really want to donate their traffic and donate their bandwidth to help out with making users able to be anonymous on the internet. And there are probably a few bad ones. So one of the ongoing research questions is, how do you tolerate a few bad nodes? Because if there's only one, then they're never going to learn that Alice is talking to Bob. And if there are, 5 or 10 out of 2,000, your odds are still pretty good. So that's still something we need to think about harder. Another exciting point. We'd really like to get some sort of general sense of how many people are using Tor and what countries they're coming from, stuff like that. So that we know what we should focus on, what features we should work on, what translations we should make sure we have next in Vidalia and Tor button, stuff like that. On the other hand, it's an anonymity network, so we don't really want to know how many users are using Tor and where they're coming from and stuff like that. So there's definitely a tension there. Right now, if you run a directory mirror, then you can watch all the different users connect to you, and you can get some sense of who's using Tor. Again, you're not learning that Alice is talking to Bob, you're just getting a list of the different Alices out there. And we'd like to fix that at some point. The next step is similar to the entry guards, where you pick 3 or 4 nodes and you always start at them. We should pick 3 or 4 directory caches and you always use them. And that means that there isn't any place you can go to enumerate a set of who's using Tor right now. On the other hand, we still want to be able to collect some aggregate data about how many users there are and what countries they're coming from. So one approach might be that we could start having every relay make a little anonymized summary of the past day, where you say, well, give or take 10%, I saw 100 users from the US and 70 users from Germany and 200 users from China. And if we can do that in a way that you can add them up and get a useful number without aiding traffic analysis, then we'd be in good shape. So another thing that we'd like to solve. Okay, other fun stuff. Turns out there are some jerks on the internet. Turns out that some of them use Tor. And that means that certain services out there that can't do authentication end up blocking all of Tor. For example, Slashdot does not let you post through Tor, because some jerk said Slashdot sucks enough times through Tor. Wikipedia does not let you edit through Tor, because some jerk wrote Wikipedia sucks on enough different pages through Tor. And a bunch of IRC networks don't let you show up through Tor, because there are enough trolls and jerks on IRC already that they couldn't handle even more. So there are a couple of success stories. For some of the IRC networks out there, like Freenode, they were having problems with people showing up through Tor, and they had a lot of different connections, and suddenly there were like 30 people in one channel coming through Tor, and then they all started yelling at each other, and mass chaos ensued, and they had to shut down the channel. And that was no good, because Tor was basically DOSing their communications. So originally they said, okay, well, we're going to figure out all the Tor servers, and we're going to block connections from those. But soon after, they realized all we really need to do is figure out the Tor users and label them as Tor users. So now when somebody shows up to Freenode using Tor, it says a Tor user has shown up. We don't know which one because it's anonymous, but this guy's coming from Tor. So that means that when 30 people try to subtly join your channel, all coming from Tor, then you say a Tor user and another one and a third one and a fourth one, hey, I'm about to be attacked. So this means that the jerks who were doing that went back to using open proxies and bot networks and whatever they were using before. They stopped using Tor because it wasn't the best way to attack. So you don't have to perfectly lock out all abuse. You just have to make sure that you're not the easiest avenue for abuse. So that's one success story. There are a couple of other things to think about on this topic. For example, there are a lot of network and sysadmins out there who think that Tor couldn't possibly have very many users. They figure that there are 6 people somewhere in the world using Tor, and they see one jerk show up through Tor. So then they say, you know, one of your 6 users is an idiot. Tor is stupid. And it's hard to explain this to them because they don't realize that we've got 250,000 people just using Tor for normal internet hygiene, so they can go to Amazon and not have Amazon build big databases about them and all the other reasons that people use Tor. So there's an easy fallacy to fall into where you figure that Tor has no users and therefore you see one bad case and you figure that all Tor users are bad. Because if Tor is working, you don't see anything. If people are anonymous, then you don't know about them. And then the flip side of that, right now Wikipedia blocks thousands and thousands, I think it might even be millions of IP addresses, because they're constantly in a hunt to find every possible bad IP address on the internet. And it turns out there are a lot of bad IP addresses on the internet because every Windows XP computer is quite likely to be a bad IP address over the course of its life. So that means Wikipedia is in a constant battle with AOL users and open proxies and Tor and universities and dynamic IP addresses and everything like that. Okay, so there are a couple of fixes we might think about. One of them is, wouldn't it be nice if Wikipedia would allow Tor users to connect, but it should treat them differently, like the Freenode IRC case. Right now, Wikipedia doesn't want to introduce any barriers to contributors. It doesn't want to make you log into an account. It doesn't want to make you do anything. You should just be able to show up and edit. But at the same time, they block hundreds of thousands of IP addresses. So how can we balance that somehow? One of them would be, if it's an IP that you trust right now, then you should just let it in, let it do whatever you normally do. But if it's one that you would normally block, you should put some speed bumps there. You should make them solve 7 CAPTCHAs in a row if you really hate that IP address. And that means that they can still do it if they care, but you're slowing down the jerks enough that they'll go somewhere else. Another approach might be you should make them log in, and then they'll have an account. And if the account doesn't have any history of editing well, then the edits that they make should go into some place that has to be manually checked. And if they've done 3 good edits, then you whitelist the account, and then they can edit from any IP address, even the one that happens to have a jerk living next door, because this account is useful, even though the IP address is a little bit sketchy. So that would hopefully be enough to send the abusers back to using their AOL or their open proxies or whatever they're using right now. And if that doesn't work, there are some other approaches that don't have to change Wikipedia as much at all. There's a system out there called NIM, written by Jason Holt, who is now at Google, I think, and another one called Nimble, written by some researchers at Dartmouth. And the idea is that so there's a multi-phase registration process where at the first part you say, this is my scarce resource, and it's mine and not very many people have it. For example, this is my IP address, or this is my $10 bill, or whatever sort of scarce resource you have in mind. And at that point you get a token that you get to use to log into Wikipedia or log into Slashdot or something. And as soon as Wikipedia says, that token abused me, I don't want to hear from it again, then you can blacklist the token without ever needing to learn the IP address associated with it. So you can make sure you never hear from that guy again, but there's no way to learn who he was. So these are some neat new designs, and we're hopefully going to try to build a few of them. And this means that we can build all this token stuff separately from the service, which means that you can have basically accounts that you make, so Wikipedia doesn't have to make accounts, and tokens that you make so Slashdot doesn't have to enforce all of this. And this means that there's some centralized place where we make Tor compatible with these services without having to force every single service to change. And there are a couple of other things we've been doing to make this easier. One of them, if you go to exitlist.torproject.org, you can fetch some software or do some DNS blacklist style queries where you say, this is my IP address and my port, and that's the IP address I'm curious about. Is that a Tor exit node? And that means that you can very easily, using a DNS-style interface, check to see if it's a Tor user showing up or not. And hopefully that will make people more amenable to doing something more than just blocking it, because they can easily check, and then they should treat them differently, however makes sense for them. And I should notice that blocking connections from the Tor network to your service is different from blocking connections from your citizens in Iran to the Tor network. We really, really object to the idea of some government or country or company blocking connections from their people to the Tor network. But we're more amenable to the idea of some service like Wikipedia saying, I'm sorry, we haven't thought much about authentication. The only option we've got for now is to block Tor, but we'll work on it. So we're happy to let them block Tor for a little while they figure out how to solve it and while we help them figure out how to solve it. So those are two different things. Okay, so those are policy, law, censorship. Couple things that we'd like to do in the future. Relay by default. We're getting closer. I had a slide earlier in the talk about how do we rate limit differently, how do we do relayed connections, how do we automatically detect IP addresses. All of that's in place. There are a few more things we need to do. One of them is it would be really great if one of the programs associated with Tor learned how to do a UPnP. So that means you can talk to the wireless router you've got and say, hey, can you open up a port and port forward it here? And that means that we don't have to say, step 4, go find the instructions for your wireless router and go figure out how to port forward, because users are never going to do that. Another approach, we need to somehow auto rate limit, because if you're on a cable modem or another asymmetric connection and you just let Tor go, then it'll fill up your pipe. And since you've got a small outbound pipe, you're going to end up dropping all your packets, even the non-Tor ones. So we really need to help people rate limit to a little bit less than the total bandwidth that they have available. And then the big question, how do we scale the network? So as the number of servers grows, the size of the directory consensus and the amount of descriptors you need to get is just going to keep on scaling up. And if we have users on modems in Iran or something like that, then we really can't have 10,000 users and say, well, before you use Tor, spend 3 hours downloading the directory information. And once you've done that, it'll be out of date. So spend another 3 hours downloading the new directory information. That can't work. And another approach is, and another issue is, as we have 10,000 servers, if we let every server connect to every other server, then we're going to have 10,000 TCP sockets open on each one of these. And Linux and BSD can handle this, but the default limit is 1024. And that means that we're going to have step 4, go figure out what a ulimit is and go change it. And that trick doesn't work for ordinary users either. So we need some sort of way to scale the network in terms of giving people information about what the topology is, and in terms of having a topology that doesn't have every single server connect to every single server. And then the last issue before everybody a relay, turns out that Windows networking is unlike every other OS we have ever heard of. And Tor servers don't work very well on Windows still. Because they don't do poll and select and stuff like that. I mean, they support it, but if you use them much, then Windows crashes. So right now we're in the state where we try to use them a lot, and then Windows crashes, and then users say, well, Tor broke my computer, and we say, well, you're running Windows. And I'd like to have a better answer than that. So we're working on all of these, and hopefully we'll get through a lot of them in 2008. Another thing to think about, incentives to relay. Wouldn't it be nice if we could give people better performance if they are a relay? Now, we need to be careful here, because the naive ways of doing this, the BitTorrent style tit for tat, I use your computer for a while, therefore you can use mine, is really scary. Because if I use your connection a lot, and then you want a fast connection, you say, who owes me a favor? Oh, Roger owes me a favor. I'll start my circuit through him. I just bought the ability to watch the first half of your circuit. So that's an easy avenue for an attacker. We'd rather have some design where it's not quite that simple. So one approach that we've been trying to simulate recently and is looking pretty good The directory authorities should make test circuits through all the different relays to audit them, to make sure that they're actually up and actually providing about the bandwidth that we think they are. And if you're a well-behaving relay, we should put a little gold star by you in the network consensus. And everybody who has a gold star gets better performance. All the other relays look at that and they say, oh, you're a well-behaving relay, I'm going to give you a priority. So this means that if you want your Tor connection to be faster, you should click the darn button that turns you into a Tor server. And then over time, people will recognize that you're better and you'll get priority. So people who click the button will benefit because they'll be getting better service. But from an economics perspective, even the people who don't click the button should benefit. Because if enough people do click the button, then the capacity grows enough that there's even more capacity for the users who don't click the button. That's the good case. The bad case is that it all falls apart. So we're still pondering that a little bit before we actually want to deploy that on the real Tor network. Okay, another thing, there's a fellow at University of Waterloo in Canada named Ian Goldberg who's thinking about UDP transport. Right now, Tor transports only TCP, which means that it's got pairwise TCP connections all the way down the path. And that means that if anybody drops a packet anywhere, then all the circuits through that connection need to wait until we find that packet or get another copy of it or something like that. So wouldn't it be nice if we could just do end-to-end UDP connections and we let the TCP connection, we let the browser and the web server handle lost packets. So that means that we're just one end-to-end TCP connection and we're moving IP packets back and forth through the network. That would also mean that we could handle UDP. We could do voice over IP as long as we could get latency for it. We could let people play Quake, though I hope that they wouldn't do that. Any sort of, UDP IP connections should be supportable at that point. On the other hand, there's a lot more research that we still have to do in terms of how do we actually make this thing scalable and perform well and stable, stuff like that. Okay, and there's also packaging issues that we've been working on. One of them is I heard from a fellow in Egypt who works on human rights there that there are a lot of bloggers in Egypt. But they all use, first of all, they use the French version of Vidalia and Firefox because there isn't an Arabic version, but we fixed that. But second of all, they all use Internet Explorer because that's what they've got, and they've never heard of Firefox. So wouldn't it be nice if we could give them a little bundle that's self-contained that has Vidalia, Tor, Polypo, Tor button, Firefox, and it all just starts by itself, it's a blob. You click Vidalia, Vidalia launches Tor, it launches Polypo, it launches Firefox once it's got a circuit ready, and then there's a special Firefox that's pre-configured to be safe. It's got Tor button on, it's got the right plugins. That'd be pretty spiffy. So that's one of the things we're working on. And Stephen Murdoch, who again will be speaking next in the other room, is working on one of those, and it looks pretty promising. So hopefully that's another way to give people Tor so that they can use it in a way that's more usable and less likely to screw up. There are other options. There are some virtual machine-based options. There's one called Janus VM. The idea is that you boot, inside your Windows, you boot a little Linux kernel, and that's got Tor, and it's got IP tables rules that intercept all outgoing TCP connections and shove them through Tor. So that means that you just click, click, and now your server is Tor, your computer is Torified. That'd be pretty nice. Another approach, there's a LiveCD out there called Incognito that people are working on, where you just pop in the CD and it boots. I think it's Gentoo based, and it's got X and a browser and all this stuff, and all of it is pre-configured to use Tor correctly, and IP tables are configured to make sure that it's either going through Tor or it gets dropped, so you can't do anything accidentally not anonymous. And then there are some folks, I think some folks around here that are working on wireless router images for the Linksys WRTG, where you can run a Tor client on your Linksys router, and then again the IP tables rules would redirect all the outgoing traffic into Tor so that you'd be anonymous by default, even though your computer is running Windows XP or whatever you happen to be running. And then there was a fellow at Yale who built his own Tor client as a Java plugin for Firefox. He hasn't built very much of it. I don't know how compatible it is, but that's certainly something to think about. On the other hand, building all of Tor as a little Java plugin, it's going to be tricky to get that one scaling well, and especially tricky to get that to be able to be a server. Okay, And then better load balancing, lots of stuff going on there that we want to think about. So Mike Perry did some measurements a while ago where he realized that we were underusing the top like fifth of the Tor servers by bandwidth. And in fact, we were missing out on like a 7-fold improvement on performance if we only load balanced better and made more use of those fast servers. So we've switched that around, and we've added 4 times as much capacity to the Tor network by better load balancing, which is pretty cool. It means, of course, that we've added 4 times as many users to the Tor network to counter that, but at least that's a good start. There's also an NDSS paper coming up from Nikita Borisov and his student at Illinois on more accurate and less gameable ways of measuring bandwidth. Rather than having the server say, I'm pretty sure this is the amount of bandwidth I have, or maybe having the server say, well, actually I've got a small amount of bandwidth, but I'm going to claim that I've got 2 gigabits per second, and then everybody will use me a lot. His goal is to have all the other servers measure each other server based on how much traffic they've been seeing, and that way they can all upload their opinions, and then the directory authority can take the consensus of them, and then we'll have a more accurate way to look at that. Okay, so there are only a few things that I've written down that we need help with. There's a page called Volunteer on the website that you should go look at, or find me outside in the hall afterwards, and I'd be happy to chat more about all sorts of things. So UPnP-based library for Vidalia. We've got a lot of translators who don't really like opening text files when they're translating strings from one to another. So some sort of web-based interface where there's a database in the back and they show up to a web page and it says, here's the string, here's the form to fill in the next one. Something like that would be really great to help us get more Farsi and other languages that our users are interested in. We've got a to-do list, volunteer page, more relays, more bridges, more funding. If you know any law enforcement in Berlin or Germany, I'm here until next week, and I'm also probably going to be coming back, so introduce me. We need more privacy advocates in Germany. I mean, there are a lot of people here at this Congress, and that's great, but you got to go out and meet other people and tell them how important it is that we live in a society where you have the ability to stay private. It'd be nice to have best practices documents for how to use Tor when you're blogging, how to use Tor when you want to use IRC or instant messaging or voice over IP, or whether it's ready to do that yet. Right now we've got pretty good instructions if you're doing browsing, but if you want to set up any other application, then we've got this horrible wiki page that's complex and you have to go down and find, oh yeah, I'm using Pigeon, here's what I change. It'd be great to have the top 5 applications that work well with Tor, stuff like that. So if you want to help us write that page or debug that page, that'd be great. We had 4 great Summer of Code students last summer working on Tor. One of them's sitting over there in a green Tor t-shirt. Hopefully Google will do its Summer of Code thing again this coming summer, and hopefully they will invite us back to have some more students. So keep an eye out on the Tor website, and hopefully in a few months we're going to have a little please submit your application for working for us for the summer. And I believe that's it. So I've got time for 10 minutes of questions. I believe there's a fellow running around with a microphone, so go to it.
As you so meticulously pointed out, that we do not want to get into traffic filtering when we are exit nodes, because you make yourself liable. But how do I explain I don't filter traffic when I don't allow IRC traffic through my exit node, which Vidalia allows at the moment? How do I explain prosecution?
From talking to lawyers, at least in the US, there's a difference between filtering traffic by port or by IP address than there is by looking at the lower level of the application level traffic and saying, not I'm filtering this based on the port, but I'm filtering this based on bytes that I saw in the stream. At least in the US, that's a big difference. In Germany, I suspect it's a big difference, but I'm not a German lawyer. That would certainly be something to put in the German legal FAQ. When we find a lawyer, you should remind us about that question. There's a microphone that's not on back there.
now it works. All right. Have you ever been expected to go to your local law enforcement and answer questions or stuff, being a terrorist or something?
Have I ever been what?
Expected to go to the police or something for being a terrorist or so?
As a Tor developer?
Yes.
No.
As you as a Tor developer.
They've left us alone. In fact, I've contacted my local FBI office and said, there's this tool on the internet that I'd like to teach you about. And I met with them at a bar nearby and taught them all about Tor. But they didn't have any idea that it existed up until that point. So if you proactively go and talk to these people when they don't think you're a criminal, then it works a lot better.
Okay, just a little comment. Can please everybody who is not currently asking a question just shut up until we have finished? Thank you.
Surely there are more. I didn't answer all of them. There's one over here.
About the statistics you showed at the beginning, I'd like to know how many of the nodes are middle nodes and how many are exit nodes. Can you tell that?
I haven't looked at the list lately, but I think about a third of those relays are exit relays, which is, from one perspective, that's exactly the right number. Because if there are 3 hops, then we need at least a third of them to be exit relays, because that way there's enough for all being in the third hop. But from an anonymity perspective, your goal is to have as much diversity as possible at the beginning, at the first hop of the network, and as much diversity as possible on the last hop of the network. So right now, if you're only exiting from a third of those servers, you're not getting as much anonymity as you could get if we had, for example, all of them be exits. So we have enough just barely for performance, but we could sure use some more for anonymity.
You said something about Germans and donations. What was that again?
Up until last night, we periodically would get mail from people saying, I'd love to give you 30 euros or something, but how do I get it to you in America? And unfortunately, our bank in America eats most of the wire transfers that come from outside. So we've been working with CCC, and they have set up a bank account in Germany so that they can accept tax-deductible donations for Tor, and then they will spend them on useful Tor things. On Tor's donate page very soon, we are going to have a particular bank account number and SWIFT number and IBAN and so on. So if you are one of those many people who are excited to donate to Tor, but you live in someplace other than the US, then we should support most of Europe tax-deductible real soon now. So thank you, CCC.
Okay, a friend of a friend and his cousin uses Windows XP with Tor, and he uses a Tor server, and he is pumping out about 100 kilobytes, so it's not much, but it's working fine. So in the course of debunking the myth that Tor isn't working well with Windows, it is possible, I would say. And,
so the details of the Windows issue. When Windows starts, when a version of Windows that does not have the word server in its name starts, it picks out what's called a non-page pool, and it specifies a certain fraction of its memory based on how much memory is in the computer, and that's the non-page pool. And every time you do a network system call, like read or write or poll or select or something like that, then you allocate a piece of that non-page pool, and that stays used until that system call is finished. So if you're doing a whole bunch of reads and a whole bunch of writes, then you start using a larger and larger piece of that non-page pool, and after a while it gets full, and then like the drivers, like the hard disk and the monitor and stuff, start failing because they get a non-page pool error, and they never check their errors because they're Windows drivers, and then like your drive crashes and it all goes bad. So once the non-page pool fills, all hell breaks loose. When you've got a computer with lots of memory, the non-page pool starts bigger, and it's less likely to fill. Also, the more bytes you push, the more likely you are to fill it. So small Windows servers with lots of memory, they do fine. Large, fast Windows servers with not much memory don't do very well. Did that help to explain? Little. Yeah, some people do it. Be sure to give it a try. It might work.
I figured out two things which I consider to be dangerous. The one is, if you have this in the Firefox, the switch proxy applet, and you loaded one page with Tor, which you know you only should load this with Tor. And then you want to load another page because your bandwidth is small, for example, you use a mobile phone. And then you switch on none, you want to load the next page, it reloads the page you already see with no proxy.
Yep.
And there's another thing. If you use Tor on a Linux or Unix system, you have to use privoxy. And there's in the wiki is written that you have to write this forward line in the privoxy config, but I haven't seen yet. I don't know if it changed in the last time. Something that you also should configure privoxy to change the browser string. And actually, I did this once and sent that the way how to change the privoxy config changed, and I didn't find the time yet to read in all the manual stuff how to do that.
Okay, so your first question is about Firefox extensions that help you start using Tor or stop using Tor. There's one called Switch Proxy, but it doesn't do everything that you want. What you really want is the little thing down here called Tor button, Tor enabled, Tor disabled. The newest version, the development version of Tor button, it's hard to see in 600 by 400 because it's down here, but there's a big pile of security settings that it's got. You can turn on or off whether you disable plugins, whether you disable cookies, whether you disable caches, and then there's history. Do I want to block history reads? There are all sorts of cross-site, cross-something or other scripting attacks where you can, on one site, learn that you visited some other site, and Tor button will turn off the ability to do that attack. There's forums. Do I really want to save everything locally? Do I want to refill? Do I want to admit to the website I'm going to? There's caches. Do I want to block the disk cache? Do I want to keep two different caches? Do I want to flush the cache when I exit? There's cookies. Do I want to clear all the cookies every time I toggle Tor? Do I want to just not accept cookies? Do I want to keep two separate cookie jars, one for when I'm using Tor, one for when I'm not? On shutdown, should I clear the cache? Should I clear the cookies? Should I clear my history? And then there's headers. Do I want to set my user agent? Do I want to not admit that my primary language is German because then I'll look a little bit different? Do I want to change other headers? So Tor button does all of this, which means that if you're using a different Firefox extension like Switch Proxy or something like that, you're not going to get these protections. So Tor button is definitely the better thing to use. And if you're doing some connections using Tor and some connections not using Tor, Tor button does its best to keep you safe even when you're doing that. So if you're in the middle of loading some page and you click disable Tor, then it'll immediately kill all the active content in that old page so that it won't reload itself later on or anything like that. So that was the first question about Tor button. The second question was, there's this privoxy thing that's recommended for use with Tor. It's an HTTP proxy, and it's kind of clunky to configure and not very safe. We're trying to get rid of our requirement for privoxy. Once upon a time, privoxy was useful for two reasons. One of them was it's a web proxy, and Firefox still isn't very good at using SOX proxies directly. And the other one was that it got rid of ads and it fixed your headers and stuff like that. Firefox is getting a lot better at both of those. It supports SOX a lot better these days, and it's got all these great privacy things built in. It does all this flushing your cookies, and it can handle changing your header. There are extensions for that. So soon, privoxy won't be relevant anymore. There's another HTTP proxy called Polypo that I like a lot more. It doesn't have privacy features built in. Its goal is to be really fast and a small, simple caching proxy. And that means that you're not going to hit the Tor network as much because it preemptively says, well, you just loaded that page. I'm pretty sure you're going to want the pictures on it. I'm going to start fetching those now, even before you started clicking on them. So it does a bunch of smart things in the background. It doesn't care about your privacy. Firefox and Tor button should do that. It just tries to make your experience faster using Tor. Did that answer that?
Well, the other thing is I like to use Tor installed on a server, and I like to use it via an SSH connection. So I don't know if this works with the Tor button plugin. For example, if I use a PDA, and actually the thing with the browser string on a PDA is very dangerous for privacy because there are not many people using the same PDA, and actually also I cannot install the same Firefox on it.
That would make it trickier. Polypo has rudimentary features for replacing headers. It deals with the referrer header and user agent and stuff like that. So that could still solve that, but our approach right now is we've got 250,000 people browsing mostly on Windows, and we'd like to switch them over to Firefox from Internet Explorer. That's step one. And there are a few people who aren't using normal browsers and stuff like that, and at this point we just hope that they're smart enough to handle it somehow. That's the best answer I can give you. We'd like to make it really easy for most people, and the rest of them hopefully can figure it out also. So if you come up with a good answer for how to do it from your PDA browser, let us know.
What about Tor for mobiles, especially for Symbian?
For mobiles?
Are you planning to do it, or?
So the question is Tor for mobile phones?
Yeah.
A few years ago, mobile phones were not fast enough to do public key encryption much. I'm told they are pretty fast these days. So that's certainly something to think about. In terms of running a Tor relay, a Tor server on your mobile, you're going to have an IP address that's the same for several hours. In the US, they don't give you these. In Germany, they might. I don't know. As mobiles get faster and they're able to do public key operations and so on, and they've got entire megabytes of memory, it becomes the same sort of question as the Linksys router. Can we run Tor on one of those? Yeah, I think we can at this point. So running a Tor client on your mobile phone should work pretty well. Another option would be you've got a computer somewhere at home and you run your Tor client on it, and then you tunnel your way through that. Just depends what privacy properties you're looking for. Okay, I've had the notion, so I'm going to be outside, and I'll be happy to answer any more questions. Thank you.